next, Team Luck.
If you'd like to introduce yourself and Team Luck, that'd be great.
Pleasure to be here. So my name is Platon Lukyanenko. I recently got my PhD from Case Western Reserve University, where I focused on physiological signal processing and human-machine interaction. So in particular, looking at muscle signals and using those to control advanced prosthetic devices. I am the entirety of Team Luck.
A one-man show. Great, like it. I thought now would be a good time to take a look at the one of your replays from one of the matches for the final submission. So Team Luck is on the red side here.
That's funny. I didn't think it'd play out that way.
So it looks like your capture agent has the flag now, is on his way back.
Mm-hmm.
And that's the game. But just having seen that for the first time, what are your initial reactions? How did your strategy play out, do you think?
Well, it seemed to do quite well against the opposing team. I'm actually really curious to see more of what the other team did, because I'm curious about how they went about addressing the challenge. I was a bit surprised that my team took as long as they did. Usually it would be something that would go about twice as fast. On that first initial sweep, when one of them went down and then tried to work its way back up, I'm surprised it missed the flag there. But it is nice that I managed to recover and identify it rather quickly.
Yeah, absolutely. I thought actually we might go back and have a look at that point where they just about missed the flag. The agents kind of, you've got your search agent, you've got your jamming agent, and they kind of almost bump into each other, or their search patterns overlap. I'm just wondering if you had any, I suppose, what your search behavior strategy was, and whether you decided to keep all of the agents' searches entirely separate, so they didn't have any overlapping parts or things like that.
Yeah, so a big part of the design was to keep them as separate as possible. That's actually what happened there. The search agent's path interfered with the jammer's path. Otherwise, the jammer would have kept going in a straight line and hit that rather quickly. So yeah, the way that worked was actually quite fun. So each drone keeps an internal map of the game space. First, that's used for traversing the area to begin with. So you run A star to get across the map and to get back. Once you're actually in the enemy space that you're trying to search. I went with a greedy sweep algorithm. So every location on the enemy territory is assigned a point value, and that point value is different for every drone. So for example, in this case, the jammer and the capturer are going to prioritize the far end of the enemy territory, and the sensor is going to prioritize kind of the middle to far row of enemy space. So each drone keeps track. It's kind of like a Roomba. Once it enters enemy territory, it just follows greedily in the direction that gives it the most points. It also keeps track of its own location and the positions of its friends so that they don't overlap the same spots. Sometimes that does turn out that they get stuck in a corner that way, but at that point they find the nearest point that they haven't looked at and go again. So it's kind of a greedy sweep with various gradients applied to the enemy territory to emphasize particular regions of it.
So I noticed that you used all three agents to do the searching. And we've got a jammer agent in there, which also has, I suppose, an offensive capability of reducing the sensor radius of an enemy agent. I'm just wondering what was behind your decision to use all three agents as part of the search, as opposed to using the jammer's offensive capability.
So the jammer reduces the enemy range to a quarter of what it is. And if we assume that the flag is randomly distributed somewhere in enemy space, if I have a jammer on defense, it's only providing me 3/4 of the value that it would provide me if it were on offense, all other things equal. It's a more effective offensive player than defensive player, unless you get very lucky and you can jam 2 enemies at once.
I'm just going to go through the video a little bit more. There's something else I want to talk about. So I notice, yeah, your agent's continuing to search that kind of bottom area. And then I think it's not too long until your jamming agent finds the flag. I think it's now found the flag, and immediately the capture agent goes straight to it. I was just wondering, so that's a really, really good example of implementing some nice communication and state sharing between the agents. Would you be able to talk through what your approach to the communication was? Or were there any particular challenges there?
Yes, so I wanted to implement an additional communication method that could be done entirely through observations between the drones. In this case, when one of the drones identifies the flag, it halts for just a frame, and then it goes and sits on the flag. And that communicates to the other agents, which are within line of sight, that the flag has been found, and here, follow me. This is where the flag is. I later noticed that that was actually something that they could see directly, but it still was an interesting communication method to build in case I wanted to have more advanced communication capabilities between them.
Do you have, I suppose, different sets of behaviors that you transition between, given, you might be in the home zone, you might have one set of behaviors, neutral zone another set, and opposing zone another set?
Yes, actually. So that's actually come back to the way that I planned out my approach to the challenge to begin with. I guess if I were to summarize that in one term, I'd use the term modular optimization. And the idea there is that you take the problem, you break it down into parts, like divide and conquer. But rather than then conquering each part and getting it to be perfect, kind of in its own little capsule, you bring everything up to a baseline first. So my first iteration was basically chance. You go in a straight line. If you hit a building, you turn left, keep going straight. Once you're in enemy territory, you basically wander around randomly. If you find the flag, you go back in a straight line. So something like that has maybe a 5% chance of working before it exhausts the simulation budget, the 1,000-second simulation time budget. So that's actually why I went with the team name of luck, because I was thinking on a scoreboard, you'd have team A, some score, team B, some score. And then as a baseline, you'd have just how far you can get by being lucky. So the idea was that after you have this baseline, what you do is you improve on whichever part is causing you the most trouble, or whichever interaction between two parts is causing the most trouble. So for example, the first thing I ran into was that my drones were crashing into buildings and getting stuck. Well, A star is pretty much the state-of-the-art method. You implement that, and then you move on to the other parts. So that handles traveling to and from the enemy space, and that just leaves searching the enemy space. My first approach there was actually to hard code paths for each drone. So I'd have the 3 drones, they'd kind of split off into 3 areas, and then each one would kind of sweep their own part of the map. Mm. And up until the last day, actually, that was the winning strategy that I had coded. I'd implemented the greedy sweep, but that kept running into errors. Well, not errors. The drones kept interfering with each other to the point that it was very inefficient, and the hard-coded path was actually more efficient. So that was actually where this idea of working on things bit by bit really shined, because I could compare cases very easily. And that allowed me to efficiently allocate resources, particularly my time and computational powers, while keeping things very understandable and easy to code and easy to debug. So here, I know exactly what the drones are doing at every step. And if I apply an artificial intelligence algorithm, in this case, the example was genetic algorithms, I'm doing that for a very particular reason, and I can give it a very small set of observations to work with. I've tuned effectively 3 parameters using the genetic algorithm, which correspond to the rows of enemy territory that the drones will prioritize. Final
question from me is, what was a key takeaway for you over the course of the challenge? What did you get out of it?
I didn't previously work with genetic algorithms, and it was very fun to see them not only work, but work really well in this context. It's something that I'd heard of and I'd seen other people use, but not something I'd practiced personally. And then I was also very pleased with the generic approach of, again, breaking down the problem and then working each part of the problem kind of separately to kind of limit the optimization space. I was surprised with how all that approach worked out.